Um, Assalamualaikum and good afternoon, everyone. So many of you are now here, 48, 47 students. So I shall begin the class despite of not having all 55 students of mine. So perhaps throughout the class, they will come in and I will admit them through. So shall we begin? Can everyone hear me? Yes, okay, good.
Yes,
All
yes, yes.
right. So just
Yes,
so you
better.
know that once I'm start presenting, that means when I'm start using my entire screen as my presenter, I couldn't see if you write something down in the chat section. Okay. So with that, you have to unmute your speaker and talk to me if you want to ask questions or want to clarify things. Just interrupt me during my talk, and then we will get. I will address your questions. Okay. So, but before that, I'm going to take the current attendance because if not, some people, if you are disconnected or whatever, I can still keep you in. All right. Okay, that's it. Now, right. So, this is Group C. So, first of all, thank you for spending your time with me in the afternoon. So, I know this is nap time, but I hope you are good. Those of you that needs to, get a break, get a coffee, makan nasi depan screen, you may do so because I can't see you. So, you can still do whatever that you want. I don't know. Is so many of you are traveling interstates yesterday. Has anyone reached home? I mean, balik kampung? Is anyone speaking to me from their kampung? No? Okay, nobody is speaking. Okay. No, stay home. All right. Okay, fine. Somebody's Fahim says stay home. So I don't know. Maybe some of you went holiday or whatever, but I'm glad everybody's here because this is online. Of course, you can do it. If you're back home, if you are in the kampung, if you are traveling, you are still once you have internet connection, you are still connecting. So just 2 hours and we'll get done. Okay. Ada yang balik cakap balik Ganu Jalil. I'm happy that you have arrived at your destination and I hope you are all safe. Okay, practice social distancing, yada. Right? So we this is the first live session that we're going to have. So we have two more live session coming. You may follow them through the schedules that I have given you at the very around last 3 weeks, around 1 of June, I think, because we have revised them. The reason why we didn't do last week live class on Wednesday last week, because I've heard from some representatives that there will be overlapping of schedules because some students have classes during that day. And why is it not done for you guys, Group C? Well, we can actually do it last week. That means week 6. But I didn't do it on week 6 prior to this week because I'm going to do it all together so that we will keep track on where we are now. Okay. So, right. So this is the updates until today. As there's still people coming in, so I need to admit them first. If not, they couldn't come in. All right. Okay. So I think we have about 50 students now. That's a good number. I think some people are disconnected because just now I admitted 4. But it's okay. Right. Okay. So these are the updates until today. Week 6. I've done the videos through YouTube's until week 9. Until the topic of Amin. Right now, working hard for week 10 videos until week 14. So I hope many of you have watched the videos. However, for Ether and Amin, if you haven't watched it, that's okay. I have seen the views is very low because perhaps we haven't reached to that week yet. So many of you are not watching it yet. All right. Now, with regards to the exercises, they are assigned as assignments in My Guru. Okay, this is done first and foremost because I don't have live session with you all week. So Some students may have difficulties in understanding some things and they couldn't ask me. So I think the wise step for me is to do exercises. So this exercise is more or less like your tutorial. It's just that I wouldn't assess them. So always remember this. Some students are worried if they do it wrongly, if they do it incorrect answers. But for me, the most important thing is you try. So exercise is a practice. So as long as you do it, complete it, and then submit them as assignments in my guru, so that I will tick you in. That means I will recognize as your attendance for the week. Of course, when we have live session, I will also take the attendance. But especially during the asynchronous videos, I don't know whether you have watched it or you haven't. With Edpuzzle, I can monitor the students, but with YouTube, I couldn't, right? Because I don't know who watched and who didn't. But I can estimate based on the numbers. Okay. These are the scheduled live session for now. The next one that we are going to have is on Thursday, 2nd of July. Basically discussing the topic of alkene and the rest around the chapters of alkene. Okay, of course, if you have questions pending from previous courses, from previous chapters, you may ask also. Likewise, in this live class. All right, now these are your assessments and coursework for now. Individual assignments, these have been done very early on. So your midterm tests have been completed on the 29th of May, and I actually have marked them and I have released the marks. I don't know how many of you have seen your marks, but that will be your marks for midterm tests, right? Now we are approaching 26th of June. That means about 15 days away. So you still have time, about 2 weeks left for you to complete group assignments and practical reports. Throughout the weeks, I have received several questions from your class representatives. That means across Group A, B, and C regarding these 2 assessments. Practical reports, some of you are asking because some of you didn't see attachments in my guru section. So what is the one that I attached is basically the same thing that is in your lab manual for data section. Because I'm afraid some of you didn't bring your lab manual back home, but then I've seen that you can still download the lab manual and the data section there. If you have no access for printer, you may do it like handwriting things down, and then scan them using Cam Scanner app, or if you have scanner, using the scanner, right? What should be written there is basically just observation, especially for experiment 4, just observation for saponification, what is happening, and then write the reaction down. And then for experiment 1, I have detailed everything in the My Guru instructions. So pay attention to it. You can get it done. Some people ask me, because I said, if you manage to do it on your own, using whatever that's around you, perhaps you want to use tree twigs, ranting, whatever that you want to, do your molecular model, then you can do so, right? But that is not a necessity. That's not compulsory. That's just for me. If you've done it, it's interesting for me to see, right? For group assignments, some people ask me whether you want to focus on one literature and then the rest is adding. So I did not actually have any strict or restrictions, okay? No strict judgment or restrictions for that particular assessments. It's more or less follow the format and you may do it on your own. Some people ask me, Doctor, can I include a figure or a mind map of sort? Yes, you can, because that is from your reading, okay? As long as you have all the requirements that's needed, then that's okay, okay? Do you have Group C, because there are so many of you, do you have questions regarding these assessments? Ada tak? If you don't have questions, I will keep going. No? All right. So this is the very first thing that, let me get back to that slide later. So the most important thing about organic chemistry is its main components. Previously, the one that you have learned, hybridization, chemical bonding, stereochemistry, are all the basic, the fundamentals of organic chemistry. What are the main components? Okay, the first main component is actually the previous slide, the functional groups. Okay, that is the most crucial, the functional groups. Okay, so then what's next is actually your IUPAC naming. If you fail to distinguish the functional groups that exist in organic chemistry, of course, you then cannot name the compounds. Okay, and then what's done is what we call as reactions and synthesis. Some students are confused with these two terms. Okay, with these two terms. So say I have A that goes to B. Okay, A is producing B using the reagent. Okay, for this particular thing, this is essentially reactions of A. However, it is synthesis of B. Now you have to know that for organic chemistry, starting from alkene unto the topic of especially carboxylic acid and derivatives, they are all interrelated. When I talk about alkene, I may as well talk about alkene. When I talk about alcohol, I will talk about alkyl halide. You cannot discuss them in silo. You have to discuss them together. So once you know about this reaction, for example, I have something like that. An alkene reacts with hydrogen with a catalyst called palladium. So usually what's underneath are catalysts or solvents. Okay, sometimes they are necessary. For example, peroxide in the dehydration reaction of alkene to make alcohol, but sometimes they are not necessary. For example, Lucas reagent, you don't need to write every solvent that's there because you are doing basic organic chemistry. You are not 8013. For me, it is suffice for you to know what is the reagent that involved. Of course, for hydrogen hydrogenation, you may as well write whatever catalyst that's there. For example, palladium, platinum, or nickel catalyst. So they will make what we call as alkane. This is called as prop 1-ene. They will make propane. So essentially, this is reaction of alkene. Okay, reaction of alkene. However, they are also synthesis of alkane. So we are discussing two chapters at one reaction. Do you get it? Now, in addition to all of this, of course, we have what we call, for example, about properties. Right? We have what we call as mechanism. However, in my opinion, you have to focus on the four main components first before you jump in onto, for example, mechanism, because they are more complex and you have so many chapters left, so many reactions that you have to know, you have to understand. Then only, for me, you focus on the mechanism. Okay. Now we go back to this first slide. Functional groups. Okay, now for single bonded carbon, that is hydrocarbons, alkane, for example, they are all single bond, right? Alkyl halide, also single bonded. Okay, what is alkyl halide? Basically, you have alkene part, and halide, that is halogen. And then you have alcohol, they are also single bonded, ether and amine. That's why the first cluster of chapters that you will first encounter are from alkene into amine, because all of them are single bonded, right? Then you will see the topic of alkene on week 10. Okay, on week 10 you will see alkene and then alkyne, and then we go into all of these are called carboxylic acid. All of these are called compound containing carbonyl. So what is carbonyl? Carbonyl looks like that. This is what we call as carbonyl. Carbonyl. They are carbon connected to oxygen using a double bond. They are what we call as carbonyl. After we complete alkyne, you will see the very first carbonyl, aldehyde and ketone. So aldehyde is essentially, they look like alcohol. You know, with alcohol, if you can see me, with alcohol you have alkane. You know what? You have R. Okay, for now, I hope everybody knows when I say R. R is actually alkyl. That means any sort of carbon chain, right? So with alkyl, the R, with alcohol, you have the neighboring is oxygen that connected to hydrogen, right? But with aldehyde, your neighbor is an alkyl, right? Your another neighbor is actually hydrogen. It's no longer oxygen in the middle. The middle ones is actually a carbon. The middle atom is carbon that's connected to oxygen. If you can see me, you know, the carbon connected to double bond to oxygen. The neighbor one is hydrogen, neighbor two is alkyl. That means they look like alcohol, but they don't. Okay? Now, ketone looks like ether, right? Your neighbor one is alkyl, neighbor two ether, neighbor one is alkyl, neighbor two is alkyl, another alkyl, the middle one is oxygen with ether. However, with ketone, the neighbor one is alkyl. Neighbor two is also alkyl. The middle atom is no longer oxygen, but they are carbon. Carbon connected to oxygen. Double bond connected to oxygen. So the middle one is carbon. They look like ether, but they don't look like ether. So because it is a totally different compound, because carbonyl will give you so many other additional reactions. Now, the one down here is what we call carboxylic acid and its derivatives. I miss one actually here. I miss acid chloride, where the OH in the carboxylic acid is substituted with a chlorine atom. So that is acid chloride. So some of these, for example, ester, you have seen it. I don't know whether you understand them, but all of these groups, okay, carboxylic acid, and they are derivatives, and their derivatives will undergo several similar reactions, you know, yielding some products, sometimes redundant, right? And then, okay, I'm going to erase this because if I don't erase this, it is what we call as toluene, another derivatives of benzene. So if I erase this, they are just a benzene. So this will be your very last chapter that you will go through. Okay, one student is come in, so I need to address them. Hold on. All right, so we have 51 now. Okay, so in addition to the functional groups, of course, you have to know the IUPAC naming. Okay, these are the IUPAC naming procedures simplified by me. Okay, because essentially until because with benzene and its derivatives, it has their own naming. Okay, it has its own unique naming, but with the rest of functional groups, starting from alkane, it will follow more or less similar namings. Not more or less, but the fundamentals are the same. Okay, until the topic of carboxylic acid and derivatives. So the first one actually is to find the longest chain containing highest priority functional group. Containing highest priority functional groups. Okay, if there is more than one functional groups, you will then need to identify which one is the higher priority. Then that will be your parent chain. Second, you need to number the carbon with lowest number at the carbon with functional groups. Okay, you need to number the carbon. You have to find the lowest number at the carbon with functional groups. Okay, not the lowest, that means it's considerably lowest. So if you're going to start from the right, later I will show you some examples. Okay, now then see if there's other functional group present. So if there is functional group present, other functional group present, they will be considered as substituents. So now then you see, is there any other substituent present in terms of, for example, alkyl, and then you will all write the substituents down, and then you will arrange them alphabetically. Then the IUPAC naming is completed. However, some alphabetization have a challenge. Some students, this is reoccurring matters where the alphabetization is quite confusing. For example, you have multiplier prefixes such as di, tri. For example, you have 2 methyl, so you will say dimethyl. Should you consider letter D, or should you consider letter M? Now, regarding the additional information that I have found, when you find di, okay, you will consider letter M. For example, it will be disregard, okay? Di, tri, tetra, etc. You will disregard the T or D. You will use whatever that is connected to it. Now, for prefixes such as neo, for example, neopentyl, for example, butyl, butyl, you will not consider the T or the S or the N that is involved in the prefixes. Okay, you will consider what is actually the substituents alphabet. However, for cyclo, for example, you have isopropyl. You will not consider P, but you will consider I. For example, you have cycloheptyl, for example, cycloheptyl. Even though, cycloheptyl, you will not consider its H alphabet, but you will consider C. All right. Also, for alphabetizing complex substituents, in your midterm test, we have seen together the complex substituents. Okay. Where you will consider the alphabet that is firstly used. For example, dimethyl ethyl, you will consider D. Right. We're talking about the midterm. Okay. There are 5 naming questions that I've given you, with one actually a bonus of sort. Heptane, all of you got it correct. All 134 students of mine got it correct. Right. Now, with the naming, actually, some students have the challenge whereby you didn't rightfully arrange the alphabets using the right alphabetization, but because I haven't come across the topic of the exact topic of IUPACs, so I still consider them as right. Okay, so but through my observation, there are still students that have difficulty in understanding the carbon numbers. For example, it is 7 is what we call as hept, but some students, they still write it as pent. Okay, even though many of you got it right, but some students have still this challenge. Okay, now with these ones, they are arranged in priorities. In the later topic of alcohol, either alcohol or I think in the topic of alcohol, you will see the complex priority of the complete priority of functional groups. Okay, beginning from carboxylic acid and ester, and then follow through until halogens. Okay, now until alkyl halide. In the middle here, somewhere around here, you will have alkene. You will have alkene as well. So if they become the substituent, for example, chloro, fluoro, and bromo and iodo, of course, they are lower in priority in comparison to alkane. You will recognize them as substituents. Ether, it will be also substituents. If we call them alkoxy, however, the suffix is ether. For amine, if it becomes substituent, you call them amino. If it's a parent chain, you call them amine. With hydroxy, of course, the suffix is all. But when a higher priority of functional group present, you will call the alcohol substituent. They are named as hydroxy. With ketone, you can also name them as substituents. They are called oxo. When ketone becomes substituent, they are called oxo. Its suffix, however, is O-N-E, own. And aldehyde, its suffix is al. If you've seen aldehyde as substituents, you will call them formyl. Hold on, I will switch on the light of my room because I couldn't see you. So Now, alphabets, not numbers. Okay, alphabets, not numbers. This actually come true from a question of student from Group A. Group A, because they asked me certain question that this are my reply. You know, 1, 2, 3, 4, 5, 6, 7, 1. Okay, 2, 3, and then 1, 2. Okay, so you have first to find the longest chain. Now, there's no other functional group present here, so they are all alkane, right? So you meant to calculate them. 1, 2, 3, 4, 5, 6, 7. Okay, if you go 1, 2, 3, 4, 5, 6, 7 also. So I will include all of this. Hold on. Right. So all of this will be my parent chain. All of these will be my parent chain. So 1, 2, 3, 4, 5, 6, 7. Now you have to number your substituents. Okay, your substituent. No, you have to number the carbon based on what's the first substituent that it's made. For example, if you number it from left to right, the first substituent you will found at carbon 3. The first substituent will be found at carbon 3. However, if you name it from the right hand side, the first substituent that you will find is actually at carbon 2. So of course, you will choose the one that you found at carbon 2. So you will number it as 1, 2. Oh, why is it not numbered? 2, 3, 4, 5, 6, 7. Okay, now we know this is hept. Why is it hept? Because it has 7 carbon. Now they are hept because it has 7 carbons. Now what is the substituent that we have? We have 2 methyl. We have 4 isopropyl. Okay, always remember iso looks like a T junction or simpang tiga, and then you have 5 ethyl. If the students say that you want to number them, it goes 2, then 4, then 5. According to IUPAC, that will be incorrect. IUPAC principles say you have to number them. You have to name the IUPACs, complete the IUPAC naming with the with the alphabets. Okay, so of course E will comes before I or M. Between isopropyl or methyl, of course with iso, in the previous slides that you have seen, you have to consider I instead of P. So HIJKLM, so M will come last. So your compound will be named as 5 ethyl 4 isopropyl, 2 methyl heptane. Okay, any question here? You may interrupt me if you have questions. No? So of course, another thing is that functional groups, you have to consider the functional group. For example, I have this compound 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, for example. I have 8 there, and I have here something like looks like that. I have OH there, right? And then I have something that looks like that. Then that, So with these ones, of course, if you see the longest chain looks like it has 1, 2, 3, 4, 5, 6, 7, 8, 9. It has 9. However, it doesn't include the OH. Okay, always with the higher priority, you have to complete them. you have to include the carbon with the functional groups. In this case, the carbon with the functional group is OH. So this carbon, you have to include them. This carbon need to be included. Okay, so whatever it is, this will be included. Now, the option is whether you are going to the right side, that will have 1, 2, 3, 4, 5, 6 carbons, 1, 2, 3, 4, 5, 6 carbon, or you're going to the left side. That means 1, 2, 3, 4, 5, 6, 7, and 8, right? So perhaps the best way is for you to go like that. Okay. If anyone have questions, jangan malu-malu. Do not be embarrassed. Do not be shy. You are on your own in your own room or whatever space. Yes, yes.
Sorry, Doktor.
Yes, may I know who's speaking?
Fatihah.
Ya, Fatihah. Teruskan.
Boleh tak Doktor repeat kenapa kena ambil yang change kat bawah tu?
Kenapa kena ambil yang carbon yang dengan OH ni ke? Okay. Okay, of course, boleh. Sebab tadi kalau kita tengok, I'll go back to this slide. Kalau you nampak, okay, kat sini walaupun tak ada alkane ya. Kat sini walaupun tak ada alkane, alcohol is a higher priority group in comparison to alkane. Nanti dalam topic of alcohol, there will be a complete priorities of functional groups that you see alcohol is higher priorities. Apabila alcohol is higher priorities, so whatever the case is, you have to include the one with higher priority dalam you consider the longest chain tu. Maksudnya, like it or not, you have to include the carbon with the functional group with higher priority. In this case, the higher priority is OH. Okay, so that carbon with OH must be included. Okay, because alcohol sitting higher than alkane. So you cannot be alkane is the parent chain, then alcohol substituent. Got it? Boleh Fatihah? So because of the higher priority of alcohol in the priority list. Is that okay?
Okay, Doktor. Thank you.
Alright. Is anybody else? Thank you. Is anybody else have other questions? So it just interrupt me if you have questions. So because of that, this chain, so I will number them. All right. So this will number as 1, 2. Of course, when you want to number the compound, the lowest number, that means not the lowest, that means say the carbon with functional group of OH here, this carbon should not be numbered as 8 or 9, for example. You in the longest chain like this, it has to be the lowest. Okay, IUPAC always prefer the lowest numbers. So 3, 4, 5, 6, 7, and 8. Okay, so you will gather whatever that you have now. So you have right now you have 8. Because you have 8, so it's oct, right? Because whatever that we have right now, we have 8 carbon, so they are called as oct. Then you have the functional group, this one's functional group of all. Now, where is the functional group? The functional group is sitting at carbon number 2. Right? Is there other substituents? Yes, we have this one's, we have 1, this is 1, 2, and 3. So 1, 2, and 3. So you have 3 propyl, prop. You know, when 3 carbons, prop. Okay, and then we have at carbon number 6. What is that? Methyl. So you will put them together. You will put everything together, and the name will be between P and M. Who will come first? HIJKLMNOP. So M first. 6 methyl, 3 propyl, And then octan. Where is the substituent? Where is the functional group? At carbon number 2. 8-methyl, 3-propyl, octan 2-ol. Now, with this naming, you can see immediately that between a letter and a number, it should be hyphen. Between a letter and a number, it should be hyphen. That means it's sempang. But when you have two numbers, say 2, 2 dimethyl, all right? So between numbers and numbers, it's a comma. But between numbers and letters, they are hyphenated. Do you have any question? Do you have any other questions here?
Doktor nak tanya.
Yeah, who's speaking? Fatia again.
Farah.
Hi,
Farah Syahira.
Hi. Yep.
Okey, doktor nak tanya kalau oktan-duol tu kan, tapi kita tak letak dua dekat tengah tu, kita letak dua kat depan propil, dua oktanol. Boleh ke doktor?
Boleh. Of course, that one is what we call as all IUPAC naming. I will accept both. Okay, yes, boleh. Dua oktanol. No worries, thank you. It's just that with the new IUPAC, some people prefer old IUPAC. Acceptable, that's okay. It's just that my preference is the new IUPAC system because I feel that with the new IUPAC, it really tells the story. That means, for example, I have another, let me say, say I have something that looks like this, it has a double bond there, with the OH there, for example, and then I have something that looks like this, So in this case, you will consider the E pula, the in. So 1, 2, 3, 4, 5, 6. So 6 is hex, right? The all is sitting at carbon number 2. However, you now have these ones, the double bond. The double bond first appear at carbon 3, in. Double bond, when it becomes substituent, you call them in. Okay, so there's other function, either substituent, yes, you have substituent that one. Methyl at carbon 5. Okay, so 5-methyl. So you have to put all of them together. So they are called as 5-methyl okay, instead of octan, so you now have octene because of the double bond. Octene, 3 in, 2-ol. Okay, this is my preference for IUPAC naming. But of course, if some of you prefer the new IUPAC, or the old IUPAC, so that means my preference is new. So it's up to you. Still acceptable. Okay. So is there any other questions for IUPAC? Because throughout the namings of IUPAC, you will have this as fundamentals. Find the longest chain with the functional groups, and then you number the other functional group present, okay? And then you will number other substituents. You will name other substituents there, and then you will combine them all together alphabetically, and then the IUPAC naming will be completed. Ada question lagi tak? Kalau tak ada, yes. Is this Farah or Fatia or who is this?
Farah lagi.
It's okay. Yeah.
Doktor, yang pasal isopropyl tu, ada setengah orang dia buat macam satu etil, satu tolak etil-metil. Itu acceptable tak?
Yes, of course, acceptable. Yes, acceptable. The reason as on 9th of June as well, there's a question. I can't remember whether it's Group B or Group A question. Some student asked me, Doctor, if can I consider the complex substituent macam isopropyl tu sebagai naming? And you were asking about the complex one, okay? The reason why the common name is introduced, for example, isobutyl, isopropyl, butyl, sec-butyl, because they simplified the complex naming. But if you still want to follow the complex naming, that means this one, for example, it is named as 1-methyl ethyl. Yes, in a bracket, then it is still acceptable. Okay. I think in the topic of alkane, we will see this complex substituent. That means, okay, to answer your questions, you are still right. You are still right. It is not wrong at all. Okay. So another components for organic chemistry that we need to know classification. This will go across three functional groups. Okay. They are alkyl halide, alcohol, and amine. Okay. We can discuss them all together. Okay. Why is it important to know? Basically, because all three different classes will undergo different reactions. Okay. And they will go under different mechanism. Okay. But to simplify stuff, this is a helicopter view. See, I will discuss them all together so that you will see, this is very simple to understand. Okay. So we have alcohol, we have alkyl halide, and we have amine. You know, alcohol has something that connected to OH. When you see this, they are alcohol groups. You know, with alkyl halide, it is connected to X. X is a halogen atom. You know, with amine, it is connected to N. Right? Now, primary, secondary, and tertiary. With primary alcohol, it has two hydrogens and one alkyl. With alkyl halide, it also has two hydrogens with one alkyl. With amine also, it's no longer talk about the carbon, but it talk about the nitrogens there. So we can simplify this as R. Okay. But with secondary, it only has one hydrogen. We have R1, R2, two types of alkyl there. And then with, of course, with secondary class of alkyl halide, they will follow the same thing. Don't worry, every time you go into the topic of alcohol, you go into the topic of alkyl halide, and you go into the topic of amine, this will again be discussed. You can see that in the videos, you can see that in my lecture notes, okay? Now with this one also, it only have one hydrogen with another alkyl there. With tertiary alcohol, it doesn't have any more hydrogen. Everything is connected to alkyl. 1, 2, and 3. 1, 2, and 3. And then we have this one also is an alkyl. Got it? So why is it important? Firstly, I've told you earlier that we'll undergo different reaction. Okay, later I will give you an example and they will undergo different mechanism. For example, tertiary alkyl halide will always undergo SN2 reaction, while primary is not preferred to undergo SN2. Later in the topic of alkyl halide, we will see this. Right. For classification, why we need to know? For example, alcohol, say primary alcohol like that, okay, will undergo oxidation. If you use PCC, it will undergo oxidation until aldehyde only. But if you use a stronger oxidizing reagent, it will undergo, say, KMnO4. You will observe carboxylic acid. This is a primary alcohol. With secondary alcohol, for example, I have the same thing there, but no longer have one carbon. So I have no longer have two hydrogen, only one hydrogen there. That then makes them as secondary alcohol. Using, say, another oxidizing reagent, say I use chromic acid, you know, I will straightforwardly get carboxylic acid. A ketone, sorry. So what? Okay, so this is a methyl then. So because this is a methyl. Hold on. So you can see that. Okay. So this will become double bond O. Sorry guys. I think I will draw this again. Um, oh. Okay. So H2CrO4. Okay. So it will become like that. Methyl will still be there. Methyl will still be there, but then this will be changed into double bond O. So this is called ketone, functional group ketone. This will be called carboxylic acid. And this will be called aldehyde. So primary alcohol can be oxidized to either aldehyde or carboxylic acid, considering the reagent. Secondary alcohol will always be oxidized to a ketone, but tertiary alcohol, say I have third butyl alcohol like this. It doesn't have any, at C connected to OH, it doesn't have any hydrogen. So it actually cannot be oxidized. This is an oxidation state. So it cannot be oxidized. Primary can be oxidized, secondary can be oxidized, tertiary cannot be oxidized. Now with that, is there any questions for these basics ones?
Doktor,
Yes.
saya ada soalan.
Uh-huh.
Saya ada soalan berkenaan dengan ketone tu, alkohol tu.
Which one? Yeah, the one here. Which one is it?
Yang OH tu kan, contohlah kan OH ni dia letak dekat karbon nombor 2. Jadi adakah oksigen dekat ketone tu dia akan replace oksigen tu, akan replace hydroxyl group tu?
Ya. Sebab OHs bila dia oxidize, dia akan jadi something else. Macam primary, bila OH dia oxidize jadi double bond O. So dia jadi double bond O, tapi sebab sebelah dia ni ada 2 hydrogen kan. So boleh jadi O, C double bond OH untuk aldehyde. O carboxylic acid, C double bond O, OH carboxylic acid. Tapi untuk ketone, dia hanya boleh ada C double bond O je. OH jadi C double bond O je. Sebab everything else has been occupied. Always remember that carbon ada 4 tangan je kan. That's why lah, in the case of tertiary alcohol, they cannot be further oxidized. Sebab kalau you oxidizekan dia OH tu, replace jadi C double bond O, dia akan jadi carbon tu akan pegang 5 tangan. That's why it cannot be further oxidized. Boleh ke?
Saya kurang jelas pasal OH group tu. Jadi macam mana kalau OH tu diletak dekat karbon nombor 2 tu? Jadi ketone tu macam mana?
Karbon nombor 2, in this case ke yang case secondary ni ke?
Secondary tu.
Okay, so
kita kan letak nombor karbon nombor 1 kan?
Karbon nombor 2 tu? Tu karbon nombor 2? I'll give you better examples. Kejap So katalah I draw this one. Okay. Katalah tadi saya draw ni kan. So saya draw macam ni kan tadi. Okay? Betul tak?
Betul.
Dia adalah pada karbon nombor 2.
Oh.
See? Does that answer your question? So this one hanya ada 1 hydrogen je di sini, betul?
Oh, okay, jelas.
Tak apa. Saya rasa you confused dia punya numbering tadi kot. So because of that, saya ada CH3 kat sini kan. So CH3, so yang benda yang saya nak kerjakan ialah benda ini kan. So and then we will, because the mechanism will actually get out of the keluarkan H2O tu. So this one will be double bond O. Will this answer your question? Jelas tak?
Jelas. Terima kasih, Doktor.
Sama. Okay, boleh Alright. So kalau ada lagi soalan silakan. Okay, kalau tak ada soalan, I will continue with the topic of alkane, cycloalkane and alkyl halide. Of course, this is included also in your videos. However, this is an opportunity for you to ask me questions. Okay, this is a discussion. So I will go for this topic a bit faster lah than the one in the videos. Okay, so if I look at the midterm punya reports, everybody has sort of understand these things, okay, the alkane part, but some has difficulties in understanding. For example, 4 carbons is built, 5 carbon is spent. Some students are still having the difficulty in this. So those students that they will identify this, you know yourself that you still don't understand them. So make sure you understand carbon 1 apa, carbon kalau ada 10 carbon nama dia apa kat depan dia, 4 carbon nama dia apa kat depan dia. Okay. So of course with the higher boiling points, higher number of carbons, higher boiling points. So we have seen this about constitutional isomers, right? Common alkyl groups. This is why I say that it's important when mat. That means it has 1 carbon, mat, 2 carbon, add. Okay, if you fail to know that 3 carbon means propyl, that means you will have difficulties. Okay, so when you have multiple groups, see this naming. Okay, DEC because it has 10 carbons, A and E because everything is alkyl, methyl because these are all they are all 1 carbon, and then you have at carbon 2, carbon 5, and carbon 7 you have methyl, so they are called 2,5,7 trimethyl. See, between numbers and numbers they are comma. Okay, between numbers and word they are hyphen. Okay, these are more complex what do you call this? Examples. Okay, complex examples. This is what your friends talked about earlier. For example, these ones. Okay, with this one is 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 7 and 2 we have methyl, so 2,7-dimethyl. However, with this one, it is summarized as sec-butyl. That means it has, so say like that, and it has CH, and then CH3, and then we have CH2, CH3. Sec here meaning it is connected at carbon 2. So it is connected at carbon 2. So if I change the in color, so 1, 2, 3, 4. So they are connected at carbon 2. So you may want to summarize them as sec-butyl. That means everything is summarized. Or you want to name them. So this is at carbon 5. We have the substituents. Everything there it's a 4 carbons, meaning it's a butyl. It's a butyl. Okay. Oh no. 4-butyl is sec-butyl, but this ones we have to use the preferences of IUPAC. That means the longest chain is 1. Okay. The longest. Oh, why is it not? Okay. The longest chain is 1, 2, 3 there. The longest chain is propyl. Right, the longest is in propyl, but if you want to use these ones, then you no longer can summarize them as sec-butyl, but you will number them as the longest chain ones. Those that this is connected to the question that we asked earlier. Okay, connected to the question that we asked earlier. So this is 1, 2, 3. So at carbon 1, it is methyl. That's why the name is 5- in a bracket 1- methyl propyl -27-dimethyl no No need. Okay. But then you have to bring forward the methyl propyl because this is connected to the P. So that will become the complex substituent. Got it? Any other questions? So basically, isopropyl and sec-butyl is a summary, is a simplified substituent, right? Now with iso, you can see it is connected to the carbon with the T-junction there. This is another example of a more complex substituents, right? Our degree of alkyl substituents that I have explained to you earlier. For example, in this case, at carbon 5, it is connected to such large complex substituents, but the way to name them is to identify what is actually the longest chain. The longest chain there is propyl, okay? And then the substituent is methyl and ethyl at the corresponding carbons there. And then you put them all together and then you complete the naming. Any questions here? Okay, so boiling point, melting point of alkane is, somebody said, I think it was Jalil, that said that you are in Terengganu, yes? Jalil, are you here? Hello? Ada yang kata balik Ganu. So I don't know whether you are in Kerteh, so you can observe these ones. Okay, the alkane sources. They are made in the plant, So these are just ways to make a shorter chain alkane from the longer ones. And then these are the cycloalkane, cyclohexane, propane, and so on and so forth. You have the namings, okay, that you can see there. And then when cycloalkane becomes substituents. Essentially, they will become substituents when you have a longer chain there. For example, between this one, cyclohexane and cyclopentane, of course, these are only 5 carbons. This is 6 carbon. Therefore, this will become the substituents, while this one will become the main chain. Cyclohexane, main chain, cyclopentyl substituents. Macam biasa, like this ones. Okay, this one only have 4 carbons, but this one have 6 carbon. We will prefer the one with the longer chain. Can you synthesize alkane other than catalytic tadi? Cracking tadi, of course you can. You can do like my example previously, you can hydrogenate alkene or alkyne to make alkane. Okay, use hydrogen, nickel, or you want to use hydrogen, platinum. But if you want to use, for example, you want to use alkyne. If you want to use alkyne, you have to use 2 moles. You have to use 2 moles. For example, you have something like that. Oh, doesn't follow me. Oh, okay, like that. You have to use 2 mole of hydrogen, because if you use 1 mole of hydrogen, it will only be transferred to alkene. So then we have got our alkene. Other things to consider that you can reduce alkyl halide. The preference to reduce alkyl halide, is this ones. Okay, you can reduce alkyl halide using lithium aluminum hydride, the strongest reducing agent to alkene. Lithium aluminum hydride is a reducing agent that you will see over and over and over again until the topic of carboxylic acid and derivatives. You will see them again. Okay, like chromic acid, you will see them over and over again. So just so you know, lithium aluminum hydride is reducing agent. For example, potassium permanganate is oxidizing agent. Okay, so the reaction.
Semua okey ke?
Okey, saya.
Hai Saitek.
Saya okey tu.
You guys, are you still there? Are you still there?
Yes, doktor.
Okay, when did I start losing you? When did I start losing you? I just realized I've been speaking by myself. So when did I start losing you? Is it
Ya, doktor.
Alright. Okay, tak apalah. Yang ini you can go to the links and you find out. So untuk alkyl halides, so classes yang ni semua kita actually dah tengok. Okay. Masa I summarize things out. And then the IUPAC nomenclature, of course, because alkane is sitting higher than alkyl halide, so alkane there will be the main chain according to IUPAC. According to IUPAC, alkane will be the main chain, and then the halogens will be the substituents. This is example of complex substituents there. These are examples when we have two substituents where one of it is an halogen atom. Of course, the common name this is introduced basically because we want to familiarize other people than chemists, so that when you go to the pharmacist, instead of saying, for example, instead of saying tetrachloromethane, that not many people can understand. When you say I want chloroform, then people will know what you want to have. All right. Now, classification, of course, we have undergone these ones. You may also have what we call as dihalides, where you have two halogen atoms, whether it is connected to a single carbon. What we call them is geminal halide, dihalide, single connected to one carbons, or you have halogen atom connected to different carbons adjacent to one another. Adjacent meaning bersebelahan. Okay, that is what we call as vicinal dihalides. Uses of alkyl halide, you may read them. I will, okay. Now, synthesis of alkyl halide, I will sum this up. Okay, I will sum this up using the slides here. All right. So, you can make alkyl halide. For examples, I want to make CH3Cl. Katalah saya nak hasilkan something that looks like this. Okay, katalah saya nak hasilkan something that looks like this. Okay, I can make them from, for examples, alkene. React with HCl. I can do that. Or if I want to use alkane with the help of gas such as chlorine in addition to light, I can use SOCl2, a reagent that will change my OH here to Cl, or I can use the same alcohol, change this to Cl using PCl3. Okay, I can also use the same ones, alcohol using OH, but using HCl. Somebody is trying to come in, so I need to, apparently, thank you for everyone that's still here. Okay. Okay, so these are some examples. However, if you don't want to add your carbons to or Cl to the carbon that's involved here, you can also use this one. That is what we call as allylic halogenation. So these are talking about these carbons. The carbon next to the double bond is what we call as allylic positions. So you want to introduce your Cl not to the carbon-carbon double bond, but the carbon next to it. So you can use this using Cl2 with 400 degrees Celsius, or you can use the reagent called NBS, N-bromo succinamide. Okay. So these are the reaction mechanisms that you can follow with SN1, SN2, and E when they need to. So reactions of alkyl halides, there are two main things to know. We have substitutions, we have elimination. Substitution is basically you want to change your halogen to a nucleophile there. Elimination is when you want to synthesize double bonds. Okay, so nucleophilic substitution can be SN1, SN2, or E1 and E2. Okay, so these are when usually students fall into a very deep hole and start to burying themselves in that hole. Okay, So there are, yeah, again, this is the reactions of alkyl halide. Alkyl halide can be used to synthesize ether, Williamson ether synthesis. Alkyl halide can be also used to synthesize alcohol. So there are many slides concerning the synthesis of alkyl halide mechanisms. Okay. Before I show you the web link for that synthesis or mechanisms involving alkyl halide, so I'll show you what we call a Zaitsev rule. Zaitsev. Tadi kita tengok Markovnikov. Previously, we have seen Markovnikov. Markovnikov rule said you have to add hydrogen to carbon with more hydrogens. Okay, add hydrogens to carbon with more hydrogens. This is involved in transferring double bonds to alcohol, transferring double bonds to alkyl halides. Okay, for example, in the case such as that one, you know, so this one has hydrogen, this one has two hydrogens. Okay, Markovnikov says, for example, in the case of that one, then you add hydrogen there, you add Cl there. In the case of making alcohol, later we will see, it says you will put OHs there. But Zaitsev pula is when you want to make a double bonds. Markovnikov is when you are reacting double bonds. Zaitsev says make double bond, okay, whatever the wordings are in the long sentences, Zaitsev say make double bond, okay, with more substituents. Okay, in this case you see there, dia buat pentene, 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Okay, one of it is making there, and you have hydrogens there. Okay. And then this one's 1, 2, 3, 4, 5. That there. So hydrogen, hydrogens, hydrogen. With more substituents, meaning make double bond with more substituents, meaning it has less hydrogen. See, more substituents means less hydrogens. Okay, so if you see, these ones have 3 hydrogens, these ones have 2 hydrogens. That's why this is a major product of Zaitsev. The remaining of the slides here talk about SN2, SN1, E2, and E1s. Okay, you can do your revisions here. But for me, the best link that I find to talk about these ones is these ones, okay? These links, you may want to see these links. Master Organic Chemistry, read up the quick and dirty guide to SN1, SN2, E1, and E2. So, okay, so it says, if it's tertiary, it definitely is not SN2, but if it's primary, see, is it containing methyl? Is it primary, secondary, or tertiary? That means your alkyl halide, is it primary, is it secondary, or is it tertiary? So if it's primary, then the reaction will almost certainly be SN2. Now this is talking about SN1 and SN2, okay? So you can read further. So these two links are also these ones. Deciding whether SN1, SN2, and E1 and E2 as well is a very, very good link that you can find. These 2 links is actually the links that I think the best in summarizing SN1, SN2, E1, and E2. Because if you start digging through, you may fall into a deeper hole of substitution and elimination mechanism. Right? So, I think I still have a couple more hours. So, a couple more hours lah, minutes saja for alcohol. Okay? Now, talking about alcohol, when I talk about alcohol now, people will see these ones. Especially with the current situation of a lot of drunk driving accidents. Right? But alcohol is not limited to this, right? Alcohol is not limited to this. With the current MCO, with the current COVID-19 situation, we have been using a lot of alcohol really as sanitizer, as disinfectant, okay? Alcohol may also be used for other things such as bioethanol for energy, for example. But when talking about alcohol, you cannot disregard the real alcohol, rum, vodka, beer. So on class on Tuesday, we have students that are Chinese, so they can drink. So they ask me a lot of questions on these ones. So I try my best to answer the questions. So if you have questions, just interrupt. Okay, for alcohols, for example, wines that actually comes from fermentation of grapes. So these are the things. But alcohol exists in our everyday life. Alcohol also is another chapter in organic chemistry. So you have these alcohols, methanol, ethanol, propanol, starting from 3 carbons onwards. You have to number the all. Starting from 3 carbons onwards, you have to number the all. Because propan 1-all, for example, propan 1-all and propan 2-all are not the same compound. They are not the same compound. So carbon 3, carbon 4, carbon 5, you need to number them, right? And then classification, luckily we have seen earlier classification. IUPAC naming, just simply add all. Okay, giving the OH the lowest number possible. We have seen all this. All right, so you can see these nomenclatures. See, you have cholesterol. Although cholesterol is such a big compound, but they are all secondary alcohols because you see these carbons containing OH only has 1 hydrogen, so it is classified as secondary. Enol. I also have given you these examples, right, where we have additional double bonds in addition to the OHs. So this is the slide that I talk about naming priorities. You see, alkene is sitting higher than halides. Alcohol is sitting higher than alkene, higher than alkane. All right. Hydroxy substituents. When OH is part of the higher priority class compound, okay. For example, this one, oic acid, if we go back to the previous slides, acid has the highest priorities. So these ones become the substituents. And a substituent is called hydroxy. Always remember that for oic acid, for acid and aldehyde, they will not be numbered, okay? Because there will be always number 1, 2, 3, and 4. The numbering is a bit wrong there. And you can also name them using common names such as isobutyl alcohol, isopropyl alcohol. But the IUPAC, when I say IUPAC naming, you have to name them correctly with that one. So naming diol is when you have 2 hydroxy in one compound. You can name them the parent chain, and then it's diol as 1 and 6, for example, in this case. Glycol for 8016 people. The science students, you will see this once again in the topic of biochemistry. Phenol nomenclature. Okay, phenol nomenclature is actually phenol. It's another substituent of benzene actually. When we go to the topic of benzene, you will be introduced to what we call as phenol. Phenol is when you have OH in addition to the benzene. Okay, OH in addition to the benzene. So if you see there, they are named as phenol, and the naming for benzene and derivatives is a bit unique, where you have meta, para, and ortho. Meta is basically at position 3, ortho position 2, para and position 4. When we go into the topic of benzene, of course, we are going to dig this further. But just so you know, this is how the naming of phenol goes. Okay, I don't know how many of you have watched the videos. Can you talk to me? How many dah buat ni? Are you still with me? Hello? Hello, everybody. Are you still with me?
Yes.
Yes, Doktor.
Okay. Have anyone work on this yet?
Doktor.
Have anyone see this video and work on this yet? Ke belum?
Belum lagi.
Belum lagi. So we will work together on this one. If you belum lagi. So if you go to these examples, always remember to include the OH there. So the option is just go to the right or go to the left. So if you go to the left, it has the more parent chain there. Okay, so this one is numbered 1, 2, 3, 4, and 5. What do we have here? We have 1, 2, 3, 4, 5. We have pant. We have 1 all, right? And then we have substituent at 2 isopropyl, right? And then we have these ones. This one is essentially a methyl. So at carbon 3, we have a methyl. But that methyl has iodine in there. So iodomethyl. If you want to put them all together, it is named as so see both of these, iso and iodo, you have to take into account the I. So between IS and IO, of course IO will come first. So its name is 3-iodomethyl 2-isopropyl. If you go to the, please watch the video for in YouTube for alcohol, because I dig this deeper into that. 2-propyl pentan 1-ol. Okay, I want you all to watch that one as well, huh? So these are physical properties. These ones yang saya nak you lihat. Alcohol have higher boiling points than ether and alkene because they can form hydrogen bonds. That's the most important thing that you should note there. Okay. So methanol, ethanol. Do you have anyone heard about methanol poisonings? Right. Previously, it happened a lot in Malaysia. So methanol poisoning is very, very dangerous because it can lead to many have died because of it. All right. So usually the people that drinks, they drink what we call as ethanol. Right. These are examples of making alcohol from alkene. Alkene, you can react with these ones, or these are all, you can see this. Okay, these are what I have gathered from the references that I found. Okay, these are talking about synthesis of alcohol from various reagents. You may start with the one containing carbonyl, such as aldehyde, such as carboxylic acid. You can reduce them using reducing agents such as lithium aluminum hydride, and then you will get alcohol. Okay, so these pula is the reactions of alcohol, and these parts are the synthesis of alcohol. So you can read this further, right? Addition to carbonyl, you can read this because we have limited time here. Okay, so these are the mechanisms. Okay, these are what we call a sodium borohydride and lithium aluminum hydride. These are reducing agent. Okay, these are reducing agent that you will come across again and again in the chapters. Okay, the next chapters you will see this again. Basically, lithium aluminum hydride is stronger. Okay, sodium borohydride is very selective. Sodium borohydride will only reduce ketone and aldehyde. But lithium aluminum hydride will reduce everything. This is an example. Okay, you have ketone there, and then you have ester part there. Sodium borohydride will only be able to reduce the ketone part to OH, but it cannot reduce the ester part. With lithium aluminum hydride, it will reduce everything. Catalytic hydrogenations is something that you can see this again. Selective reductions. Thiol is like an ester. And if you go to the topic of ether, you will see again thiol ether, where oxygen is substituted into S, and then these are all thiols. Okay, this one is something that you want to focus on. What is the reactions of alcohol? It can dehydrate to alkene. It can be oxidized to aldehyde ketone. Also carboxylic acid. It can be substituted to alkyl halide. It can be reduced to alkane. You may want to esterify them. It can be used to synthesize ether. All of these are very good to be summarized up in a mind map. Okay, sum them up in a mind map. Another good references is the forum, my group forum. There's a topic called reaction of alcohol. So you may want to put your mind map there. Okay. So it's a summary table there, something that you can look at. So I've shown you this one, oxidation to alcohol, oxidation of alcohol. Secondary alcohol will be oxidation to ketone. These ones I've shown you in the earlier part of our meeting. So these are the mechanisms. So again, you use PCC and these are what we call as chromic acid. The one that I show you is summary, but you may want to use this one as well. This is sodium dichromate with acid with sulfuric acid. Okay, so in sum up, this is a chromic acid. Okay, you will oxidize them to carboxylic acid. But if you use a limiting reagent such as PCC, it will be only oxidized to aldehyde. Okay, so I've shown you in the earlier part of our meeting. So tertiary cannot be oxidized. So you have all of these in there. Biological oxidation, something that you may want to read. And yeah, this one, it will follows the Zaitsev rule. Okay, where you want to put your double bonds. Okay, you can dehydrate with concentrated H2SO4, and then you will get alkene. Okay, so again, this is reaction of alcohol with HBr. Same thing. I've shown you the summary previously. So a reaction with HCl, Lucas reagent, and then something that you can read. Okay, PCl3, PPR3. Okay, these are examples where you just change the OH to the concerning halogens that you talk about there. All right. Now the mechanism, this is quite interesting, whereby you just push the lone pair of electrons and then you react them. I also want you to focus on these ones, the dehydration reactions. This one, please look into dehydration of alcohols. Okay, where you again use your lone pair of electrons and then you just add water there. So these are very good. Okay, E1 mechanism. So I want you to see these ones where you will push your lone pair of electron react with the H plus coming from the acid. And then when you have positively charged oxygens, your single bonded there will be pushed forward, and then you will left with a cation, okay, a positively charged carbon, and then you will use your water again to react. And then lastly, it will make a double bonds. And always follow the Zaitsev rule. All right. So I think that's about it. Esterification. In the topic of ester, we will see this again. In the topic of acid, we will see this again. Okay, likewise with acid chloride. All right, now this one we will see again in the topic of ether, where you will use alcohol that will make alkoxide. Okay, alkoxide is actually coming from alcohol reacting with a metal such as potassium, such as sodium, and then they will react with your alkyl halide. If you observe carefully, in the topic of alkyl halide, we have seen this. In the topic of alcohol, we have seen this again. In the topic of ether as well. All right. So before I end this, do we have questions?
Doktor,
Yes.
saya ada soalan tapi bukan berkenaan dengan yang ni lah, berkenaan dengan eksperimen 5 tu.
Aha.
Eksperimen 5 tu kan doktor bagi link prosedur tu kan. Lepas tu tapi video tu dia tunjuk prosedur je, dia tak tunjuk result. Jadi nak result tu macam mana doktor?
Kejap ya. So I'll go to your Kejap I'll go to. Kejap I'll go to your. Okay, so let me. Yep. Um. Okay, so this is your lab manual. Now, untuk eksperimen 4, if you seen this ones, okay, the worksheet kat sini, dia just tulis observation only. So, apa yang you tengok berlaku? Perhaps you seen dia dapat, the product is white in color ke macam mana. Or you've been saying that the video doesn't have any products. Is that what you're saying?
Betul. Maksudnya
So,
dia tak ada result, dia sampai prosedur je dia buat.
the procedure je. So, just write observation, you just write the procedure down lah. Apa yang berlaku, the procedure, what's happening. So, that is your observation. So, untuk equation, you may want to write the saponification reaction punya equation. You can always outsource you punya resources. Find other references that talk about saponification, and then in the discussion you can include that references. Boleh ke? Did I answer your questions?
Okay, terima kasih.
Yeah. So because we are no longer in the, how do I say this, in the typical experiments in the lab kind of thing. So I also do not have access to do the experiment in the lab at the time. Okay, now maybe perhaps I can, but because of these restrictions, I feel that it is suffice for me to show you the visuals and for you to know that how is the procedure being done. So if you say observation can be up until the procedure, so be it. Okay, just show me what should be happening, and then in the discussion section you may want to include what should be the product that you can observe perhaps from other references that you find. Boleh ke? Farah, is that okay with you?
Okay, Doktor.
Sama.
Okay.
So is there any more questions coming from you guys? Hello everybody. Do you have more questions? No? So far no. Norani Shaira said no, doctor. Okay. Why are you not speaking? Are you embarrassed or are you what? Are you with people now? Can always talk to me, Alright. Okay, so if you don't have any more questions, kelas 31 hari bulan, doktor. Jala say kelas 31 hari bulan. Yeah, according to my, bukan Raya Haji ke? Oh, is that Raya Haji? Hold on. Let me see, where's my execution dates? 30 Jun. Raya Haji is when? Jalil, can you talk to me because I couldn't see you punya chatting dah. 31 Julai Raya Haji. 30 Julai belum Raya Haji. 30 Julai, not 31. On Thursday 30 Julai. Jalil, are you there? Oh, 30 Julai. 30 Julai. Oh, sorry, you didn't, hold on. Tadi I show you the ni, you didn't see. This one. Sekejap ya. Where was I? This one. So kalau you tengok kat dalam hi Faizan Hafiz, you just switch on your here. Dekat sini. Kalau you tengok kat sini, the one yang I gave you earlier kan, yang on the ni saya bagi pada class rep, and then class rep forward pada you, saya memang letak kat sini 30 Julai. Okay? Is everybody okay? So it's 30 July. Alright, can you see this? Alright 30 Julai, not 31. Okay, clear, good. Okay, with that, kalau tak ada apa-apa, saya nak conclude the session. And I wish you all the best for the remaining chapters, from time to time, you may want to subscribe to my channel. You may want to subscribe to see the latest videos that I have. Okay, so thank you so much. Take care, everyone. That's all for the class today. Bye bye. Thank you. Terima kasih banyak. Thank you. Thank you
Thank
so
you,
much.
doktor. Jangan lupa like.
Thank you,
Jangan lupa apa?
doktor.
Okay. Thank you, doktor. Thank you, doktor.
Jangan lupa apa?
Thank you, doktor.
Apa dia Jalil hanya cakap? Jangan lupa apa? Thank you. Thank you, everybody.
Thank you, doktor.
Thank you so much. Thank you, everyone. Thank you for coming. Thank you.